See here we know the three vectors, unit vectors like I cap, j cap and k cap. Suppose you have taken three axes like this is here, this is x, y and z. This is I cap, this is j cap, this is k cap. So, if you are taking I cross j, so we can write I cross j is equal to k cap. J cross k, you can write here j cross k is equal to I cap, and here k cross I is equal to, you can write is equal to j cap. If you take there here like this is here j cross I, that will be equal to minus k cap. So, when you are multiplying I and j, so the cross product is along k cap, and when you are multiplying j and I, j cross I, j cap cross I cap, then its direction is along minus k cap. Similarly, you can write k cap cross j cap is equal to minus I cap, and I cap cross k cap is equal to minus j cap. So, all these cross products are perpendicular to the two vectors, and now see here in this case, in these cases, and from here also we can say, we cannot write here A cross B does not equal to B cross A. So, it does not obey here commutative law, because A cross B is supposed along the j cap. So, the B cross A will be here along the minus j cap. Now, we know this thing is here like A cross B is equal to magnitude of A, magnitude of B, sin theta c cap. If you are taking theta is equal to 0 or 180 degree, then you will be getting here A cross B is equal to 0. That means here if you are taking I cap cross I cap, j cap cross j cap, k cap cross k cap is equal to, it will be 0. So, here this is here important thing which you have to again keep in your mind for solving the questions. So, in this topic a vector product or cross product of two vectors. So, one more concept is here, that is a geometrical interpretation of cross product of two vectors. So, let us understand this topic. Suppose you have got two vectors, so one is suppose A over here and another is vector B. This is angle theta, angle between the two vectors, this point is O. We can make here a parallelogram like this. This is OP and this we can take R, this we can take as Q, and here we are drawing a perpendicular, suppose N. So, we can write magnitude of A cross B is equal to A B sin theta, and this will be here B sin theta, its component. So, we can write here A is represented by OP and B sin theta is represented by QN. So, this you can write area of parallelogram OPRQ. It means magnitude of cross product of two vector is equal to area of parallelogram OPRQ. Similarly, we can write here A cross B is equal to twice of OP into QN divided by 2, and if you join this is here, see here OP into QN upon 2, that is the area of triangle OPQ. So, we can write here twice of area of triangle OPQ. So, here magnitude of the cross product of two vector, first thing is equal to area of parallelogram OPRQ, and second one is here magnitude of the cross product of two vector is representing twice of the area of triangle OPQ when the two vectors A and B are representing the two sides of a triangle. Similarly, in case of the parallelogram, two vectors A and B are representing the two sides of the parallelogram. Say a cross product of two vectors does not obey commutative law, we have done already. So, but it obeys distributive property, that you can say distributive law or associative law. For distributive law, suppose if you have got A cross here B plus C, you can write here A cross B plus B cross C. It obeys also associative property. But one more important thing is there are certain examples of the cross product of two vectors. First, you can take example of the torque. Torque is equal to R cross F. That is an example of the cross product of two vectors. Similarly, we can write L, that is angular momentum is equal to R cross P. So, this quantity is also an example of the cross product of two vectors.